Good morning, everybody, and welcome. This is quite an exciting day for me. I'm Lindi Botha. I'm an agricultural journalist and communication specialist. I've been in this industry for about 13 years now, and one of my very first media trips that I took as an agricultural journalist was with Monsanto to cotton farmers. And so my journey with GMOs started, and fortunately through all the education media programs that Monsanto held in those days, I got to terms with the technology and a good understanding of what it was about, and out the window went all of these dreaded ideas about how terrible GMOs are that the general public has, and also, of course, mainstream media, since we all love sensation so much. So it was an eye-opening experience for me, and since then I've really just fallen in love with the technology just because of the benefits that it really brings. So I'm excited to have everybody here in the room today where we can really delve into new breeding technologies, into gene editing, and this new era that we are going into with this technology. So welcome to everybody. We are going to start off with the very first session on regulation. I am chairing this discussion. I sound biased for sure in saying that I think this is the most important session of the day, but at the end of the day, it doesn't matter how wonderful the technology is if we don't have the regulation to implement it. It's like having the best, most amazing car in the world that runs on thin air, but we don't have the keys to use it. So we're not going to go anywhere and the whole world is going to pass us by while this beautiful piece of technology just stands idle. So I'd like to first of all welcome Hennie, Groenewald, the CEO of Biosafety, just to do the welcome, and then we are going to kick off with the first speaker in this session, who is Dr. Roy Mugiira. He's tuning in all the way from Kenya, and he is the CEO of the National Biosafety Authority of Kenya. He holds a PhD in the diagnosis of plant viral infections based on the alignment of their DNA sequences. He has research experience in the cloning of viral DNA genomes into gene silencing vectors for application in functional genomics. Dr. Mugiira played a key role in the development of Kenya's biotechnology development policy and the biosafety regulatory framework for genetically modified organisms. He's the national focal point for the Cartagena Protocol for biosafety. Thank you.
We'll come back to you just in 5 minutes. Good morning, everybody. I think the first thing is it's so nice to see everybody. It's amazing how small the community is and the energy that I saw outside. I haven't said morning to everybody, but I've been talking about genome editing now for 8 years, and I think there's always value in having somebody in front of you that they can look you in the eye and say what they want to say, and I can say what I want to say. So welcome. The reason why we're here and why we focus, you all know this is the fourth, what we call Sustainable Bio-Innovation. This is what Biosafety South Africa does. It helps and it facilitates bio-innovation on lots of different ways that I'm not going to talk about today. But bringing people together and talking about things, and genome editing is the talk today. So this started, I think the urgency for this is, I think we were 6 or 8 South Africans at the International Society for Biosafety Research meeting in May in St. Louis. And often, as South Africans do, we got together every once in a while, shared a beer and at least a coffee at the place. And one of the things that we discussed there is that, the energy that we felt there and the excitement that was there about innovation specifically in genome editing, we didn't experience that in South Africa. So today is about talking about those things. Why is it not here? I must say, since I came back, one of the things that I was concerned about is, especially in the early research and development area, at academic institutions and the CSIR and places like that, the research councils, is that I didn't know of all the activity that's going on. So since May, I made it my job to find out a little bit more, and I must say, I'm surprised about the amount of stuff that's going on there. So today's sessions, we're going to talk about regulation. We all know how important regulation is. The second thing we're going to talk about is the practical stuff. And this also comes from the community that you said what you want to talk about. And the third one, we're going to talk specifically about what I call innovation management. And it's a very vague term that I use there, but the idea is there to talk about how do we improve, what do we need to really make innovation an issue. So you would see on my program, actually right at the top, I put in there the objectives. We're not just here to have a general discussion. I would love us to go away from here with a list of things that we need to do to ensure that genome editing innovation in South Africa works. And innovation, in my opinion, only works when there are products, there are people in jobs to, make those products. So that's what it's about. We need to do, obviously, the initial research and development and all that stuff. But how do we, and this is a discussion that's been haunting South Africa and the bioeconomy and biotechnology for a long time. So this is the last session, again, coming back to that. That's the focus. But we need an empowering and an enabling environment in which to do that. So what do we need to do? I would love to walk out of here if you tell me priority number one is 200 million rands. We will go to DSI and tell them we need 200 million rands. So anything that you think is going to get us there, this is why we're here. So welcome. I hope we're going to go there. Lindi already introduced Roy, so I'm just going to get him on the system. I hope he hears us. Unfortunately, everything was organized for his trip, and he would have joined us today, but the Kenya government put a moratorium on travel just last week, so he can't join us physically, but he's here in spirit. And you will see the last thing I want to say in the welcome is we will have fairly short presentation, except for the two kind of keynotes, the one from Roy, and then this afternoon after lunch we have somebody from the USA, which sent us a pre-recorded presentation. The rest are just 10 minutes because you will see we have these long discussion times. So it means this is not one of those meetings where you come and you just listen and stare at the slides. We want you to participate. We're not going to get to those goals that I just listed if you do not participate. So please, let's do this for genome editing innovation in South Africa. Welcome everybody, thanks. And then I'm going to introduce not introduce Roy, but just bring him online.
Yes, and thank you very much, Hennie, and colleagues from South Africa. Good morning. We are 1 hour ahead of South Africa, so we had some little more time to prepare. I am joined by my colleague Anne Mugiira, who is a senior biosafety officer at the National Biosafety Authority, basically for backup, so that in case there are too difficult technical things that may be asked, then Anne will step in to help with this. Anne, you could say jambo to our colleagues in South.
Jambo to South African colleagues.
Good. Once again, colleagues and friends, I am delighted to join you. Unfortunately, I couldn't be there physically. The disadvantage of not being there physically is that when I'm here, some other roles show up, and therefore we will be able to be with you for this morning session, and possibly later in the afternoon we may step out, because again, your meeting was not organized to be entirely online. I am the Chief Executive Officer of the National Biosafety Authority, and I want to thank the organizers of this symposium for asking me to make a presentation. I will run the slides. The first few slides will basically show the convergence of our regulatory system between Kenya and South Africa. They are basically designed to show that what you do in South Africa for GM technology is exactly what we do, and our regulatory framework stems from the same global protocol, the Cartagena Protocol on biosafety. I will therefore move through those very fast slides quite quickly, but then I will settle around genome editing, because the subject of this symposium is enabling genome editing-based innovations in South Africa. Next slide. The Kenya's biosafety regulatory framework stems from the Cartagena Protocol, which is, I think I'm just doing this to show that both Kenya's and South Africa's biosafety regulatory framework comes from the same stem. which is a protocol under the Convention on Biological Diversity. We signed this in 2000 and ratified it in 2003, clearly demonstrating Kenya's commitment to the global governance of modern biotechnology and biodiversity conservation. We also expressed our aspirations as a country to become a key participant in the global biotechnology enterprise within 10 years, and this was done in 2006 when we developed the National Biotechnology Development Policy. Next slide. The Kenya's National Biosafety Framework comprised of a policy which was developed in 2006 called the National Biotechnology Development Policy, from which stemmed the Biosafety Act, which established the National Biosafety Authority, the institution that I head as the National Competent Authority, and we have developed 4 regulations as indicated there, which I am sure, I know that Mugiira, what also is being implemented in South Africa for contained use, for export, import, and transit, for environmental release, and also for labeling. Shortly after we did this, our country imposed a ban on GM foods that was lifted not too long ago last year. So we didn't have the opportunity to apply some of these regulations, but we are now picking them up after the lifting of the ban. Next slide. In the execution of our biosafety regulatory mandate, we work with other regulatory agencies. And these ones that are displayed here are the key ones, 8 of them that are provided for in the Act, recognizing that biotechnology is cross-cutting. It is applied in health, in vet, in standards, in industry, in plants, and so on. So we have the the Department of Public Health, the Department of Veterinary Services, the Kenya Bureau of Standards, the Kenya Plant Health Inspectorate Service, the Kenya Industrial Property Institute, the Kenya Wildlife Service, the Pesticide Control Products Board, and the National Environment Management Authority. All these agencies, we work together as together with the institutional biosafety committees in the execution of our mandate. So if an element has something to do with plants, KEFIS steps in, then we do what needs to be done. If it is an item that touches on CITES and protected areas, KWS comes in. And if there are issues around intellectual property, then KIPI, we bring them in to provide their expertise and so on. Next slide. Within our regulatory framework, Kenya, we have approved BT cotton. This is cotton that is genetically engineered to resist the cotton bollworm. It was commercialized in 2020, and we are getting, I think, the 5th cycle of its cultivation. We have also approved BT maize, and these ones are awaiting variety release by KEFIS so that they can get into the market. We were just about to roll out these particular seeds, but some people went to court, and we are battling some court cases, petitions, which after that is sorted out, then we'll move on. Incidentally, the seeds for BT maize that will be cultivated here in Kenya has been developed in South Africa. And we understand that it is somewhere in a store, someplace, I think in either in Joburg or Cape Town, I'm not very sure where, but awaiting clearance of the court issues, and then the seed will be able to come this way. The third GM crop that we have approved is the virus-resistant cassava, which is resistant to the cassava brown streak disease, and this is national performance trials are being conducted under the supervision of KEFIS. Next slide. Our approach to approval of biosafety for confined field trials. I just use this slide to illustrate similarity of what we do and what our South African counterparts do. The application is received, it's taken through experts, reviewers, and regulatory agencies. Then the reviewers give their opinion. This goes to the board, and then the board either approves or rejects, and then monitoring and appeal. Those are other things that follow. This is for GM, genetically modified organisms or crops. Next slide. For purposes of by environmental release, the process is a bit more rigorous. You can see the second level after the application is received and checked by the Secretariat. There is a large number of people that come to act. Number one, we give a public notice for purposes of public participation in newspapers and media outlets so that the public can give their views. We also engage socioeconomic experts and then the regulatory agencies and the biosafety experts. Their input or their contribution is consolidated, and then it is taken to the technical committee of the board, and then eventually to the board with a recommendation either to approve or reject. And the three items that I have shown out there, the BT maize, BT cotton, and virus-resistant cassava has gone through this process. Next slide. Now closer home to the subject of this symposium, the emergence of genome editing. As a champion of women and girls empowerment, I cannot fail to show this photograph of these two ladies, Jennifer and Emanuela, who jointly were awarded the Nobel Prize in Chemistry in 2020 for their work in the development of a method for genome editing. Now, this is an emerging technology tools such as genome editing and also synthetic biology are presenting newer frontiers in the application of modern biotechnology for socioeconomic development. This is a new page that is opening, allowing scientists to modify, to edit genomes for beneficial purposes. And one thing, when this came into the fall, the question came in, is this to be regulated under the biosafety framework, or is this to be regulated outside that framework? And discussions even at the global level under the Convention on Biological Diversity, the Cartagena Protocol, are still going on. But nevertheless, we needed to step forward quickly and see that this technology becomes useful to our people by developing guidelines. So how does this proceed? Basically, I will not go to the details of this. I think the afternoon session will cover quite a bit of this. Genome editing proceeds in three distinct pathways. The first is a pathway where neither the intermediates nor the final product is a GMO. In the classical definition of a GMO as an organism that carries a novel gene fragment from a different source. The second pathway is where there are intermediates in the process that involve novel gene, but then the end product is without traces of the novel gene from another organism. And finally, the other pathway is one that involves a novel gene, which is also found in the final product, and therefore ending in that which can be defined in the classical sense as a GMO. So these are the three principal pathways of genome editing. Next slide. So when this became apparent, we developed guidelines as a country to provide technical guidance to applicants on the criteria for determining which genome editing organisms or their derived end products should be regulated under the Biosafety Act. And the key features of our guidelines, number one, is an early consultation stage, where the applicant fills out a simple form providing information and data that facilitate decision making. The second feature is expeditious timelines. We do this within 30 days for decision making at the early consultation stage, and we have also made it quite easy to fill in the form and flow with that. The third feature is a clear flow of steps on consideration of the various options on the basis of information or data that is provided. And finally, is the categorization of genome editing outcomes expected to be regulated under the Biosafety Act. We learned this from our colleagues from Argentina. Shortly when this became possible, we had a bilateral workshop where the Argentinian counterparts demonstrated to us how they deal with this. And we picked it because it is clearly science-based, and it is based on what outcomes come out of the process of genome editing. And it is important to note that the same approach has been taken by a number of other countries, as we are going to show shortly. So this is came about out of taking courage, recognizing that our Biosafety Act is limited in terms of the mandate. It mandates the NBA to regulate GMOs. But then this is a process involving genetics. And therefore, we took courage and said we shall develop guidelines around this space, learning from other countries like Argentina that I have just mentioned. Next slide. We're there. Now, in the early consultation, we made it very simple, as illustrated in this flow chart. I have attended workshops. I think I was in St. Louis early this year, and I have seen several other countries actually having the same kind of flow, where at the start, the early consultations with NBA, the applicant fills in and submits the prescribed form. Then we check it for completeness and accuracy of the information that is given. Then the question we ask, is there integration of foreign DNA sequence? If the answer is no, then we categorize that as an non-GMO, and we hand it over through notification that the technique and or product will not be regulated under the Biosafety Act, and then it is handled by other regulatory agencies that deal with other matters. For example, if it is a crop for purposes of variety testing and so on, the next step goes to KEFIS. If the answer is yes, we ask the second question, is the foreign DNA sequence present in the end product? If the answer is no, then again, we categorize the end product as a non-GMO, and we make the notification, again, saying this is not regulated under the Biosafety Act, and other agencies now pick it up moving down. If the answer is yes, then the conclusion is that this is a GMO, and we give notification that the technique or the product will be regulated under the Biosafety Act, and then we notify the relevant regulatory agencies, and also we notify the applicant that for this, you will have to complete a complete risk assessment dossier for purposes of safety assessment. We do this within 30 days, but we also keep asking questions if there are some aspects of the data that require clarification. Next slide. Using this process, we have handled 3 projects. Sorry to call them approval, because we actually do not approve. We analyze and pass it to the next agent. Number 1, we have dealt with gene-edited maize lines with resistance to maize lethal necrosis, the MLN disease, which is a serious problem in this part of the world. So this is now undergoing NPTs, National Performance Trials, which are now being supervised by KEFIS, the Plant Health Inspectorate Service. In essence, therefore, after going through the procedures and the processes of coming up with these lines, we concluded that these particular genome-edited maize lines do not fall within that which need to be regulated under the Biosafety Act. Number 2, we have also processed gene-edited nitrogen-fixing bacteria in the species of Cossacania sakari and Klebsiella vericola. These species of bacteria have been gene-edited to have enhanced nitrogen-fixing capabilities, and also associating with the grass family, you know, the sugarcane, the maize, and so on, and therefore they are helping in reducing the need for nitrogenous fertilizer application during cropping season. Again, KEFIS is supervising national performance trials for dressing of seedlings with these 2 bacteria. This was presented by a private sector player I think, a company called Pivot from the US, and it is fronting in the development of gene-edited microorganisms for various applications. Finally, the third one, we have also processed gene-edited sorghum lines with resistance to a parasitic weed called striga. And this is being carried out by one of our universities, the Kenyatta University, where Professor Runo is developing sorghum lines that are resistant to striga using gene editing. All these are being regulated by KEPHIS as conventional crops because our analysis and our assessment has concluded that they are not to be regulated under the Biosafety Act. Next slide. Now this one, Hennie, you will need to click on the hyperlink.
Okay, I did. It's just loading.
Control. Just a moment. Yes, and then we flow down on that document. There are slides, and find, Hennie, where there's a heading convergence, a divergence and convergence in the international regulatory policies.
It's not loading on our side. I saved the document. Just give me a moment to open it in the presentation.
Okay.
I just have to stop my slide sharing quickly.
Oh, okay, temporarily. You will pay me back my minutes.
Yes, okay. I've got the PDF open.
It's open, eh?
Yes, the plant breeding innovation,
now,
private seed sectors engagement.
Yes, go down to the page where you will find a global map, and the heading to that particular slide, or either it is a page, divergence and convergence in international regulatory policies.
A world map, you said? Yes, I've got it.
Yes, with some green and some. Aha, good. Now, this map, colleagues, shows how countries have approached genome editing, and I do not intend to go to the details. They are all labeled there. But what I want you to see is green that indicates approaches that have taken genome editing as conventional, or rather new breeding technologies as conventional, if the outcome is not GMO. So you can see the US, Canada, Brazil, Colombia, some other South American countries, Honduras, Costa Rica, Paraguay, Argentina, Chile. Crossing over to Europe, you see England. In fact, the act that is going through the UK now is tailored along our guidelines. I was very proud to imagine that a superpower like England and our former colonizers have now learned from us. And when you cross over to Africa, you will find Burkina Faso, Ghana, and Burkina Faso, you find Nigeria, Kenya, and Malawi. Crossing over to the Asian subcontinent, India, Philippines Island, Australia, Japan, and so on. You will notice the New Zealand and South Africa. These are countries that have chosen a line that genome editing is equivalent to GMO, and it is being regulated along those sites. Now, my encouragement to our counterparts in South Africa is, South Africa has had a long history and experience with GM technology or modern biotechnology, and has been a leader. And I would encourage South Africa to reclaim the leadership in Africa in applying science-based in doing guidelines for genome editing. You can see Nigeria, Kenya, and even Malawi, not too far from where you are now claiming to take your position as a leader. I don't want to go very far into that. Remember, this is a regulator sharing with colleagues, and it is not the position of Kenya as we look at South Africa, lest we have some diplomatic tiff. But again, Hennie, this is to show that this is the approach the global community has taken, and therefore we need to learn from one another. And I'm truly grateful to be able to share our approach with you in South Africa for purposes of working together. Let's go back to the slides then, Hennie.
Could you just give me a moment? Okay, I'm back at slide number 14, the desired regulatory framework.
Good. Now, what is desired when you're doing a regulatory framework, one or even guidelines? You see, I said our act, the South African Act, are very, very specific on GMO. Now, if a new system comes in, what do? We did guidelines. And number one, those must be consistent and risk proportionate. They must show that they are responding to a real potential for risk. Number two, they have to be science-based. You know, science does not attract arguments. I recall when we studied basic sciences in high school, we were taught how to check whether a solution is acid or is a base by inserting a litmus paper. If the paper turns blue, then it is an alkali. If it turns red, it is an acid, and there is no discussions around that. So a system that is science-based gives confidence that we are doing this because science is saying this. Number three, it has to be globally harmonized. From the map that you have seen, you can see there is a fairly general consensus globally on the approach to regulation of genome editing. And therefore, when we do our guidelines and encouragement that I've just mentioned, is to see that it resonates with what is happening elsewhere in the world. And four, it must be on a case-by-case basis. I visited a media house here in Kenya, and I was asked to state whether GMOs are safe or not safe. Then I said, there is no one category of things called GMOs. There is a case-by-case. There is a BT maize. There is a drought-tolerant corn. So we treat it on a case-by-case basis. This is a statement picked from a publication by the International Seed Federation, and it says plant varieties developed through the latest plant breeding methods should not be differentially regulated if they are similar or indistinguishable from varieties that could have been produced through earlier plant breeding methods. And this can be found in that publication, basically saying that if the process could have been achieved through conventional processes, then they should not be regulated differentially. For example, if you got corn flour that is obtained from a genome-edited corn and one that is obtained from non-genome-edited corn, and you put them someplace without labeling, it would be difficult for anyone to say which one is resulting from the genome editing process by any kind of analysis, because there are no markers. If it is a GMO, we know we have markers, we have things that we can check. But if it is genome edited and it has no marker to say this is the one that is genome edited and this is the one that is conventional, then it becomes difficult to regulate even at the level of the shelf. Next slide.
Yep.
Now, what does South Africa have? Number one, long experience in genetic modification of crops. For a long time, it is only South Africa, I think sometime later Egypt and Burkina Faso, that were showing crops that are GM edited. In that regard, therefore, you have a long history, a long experience. And I can share my own personal experience in a trips that we used to make to South Africa called Seeing is Believing. We brought our members of parliament to South Africa a number of times, and every time we would come there, sometimes we come back and then there is an election, so the parliament changes, some new committee members are appointed. So we dropped down to South Africa a number of times visiting a farmer, someplace not too far away from Pretoria. And so one time we visited with members of parliament, as we were arriving at the farmer's compound, members of our parliament asked, but where is the GMO? Then we told them, all this corn that you have seen as we drove here is genetically modified. And even the ugali is the food that we make with corn flour. I can't remember very well what you call it in South Africa. That you are just about to eat is made from this corn. So our members of parliament said, but we have not seen a GMO. I don't know what they expected to see. Probably they were expecting to see a maize that is as high as 10 meters, probably with eyes and ears and nose and horns. I don't know. That was their expectation. And then the interesting thing is that the farmer that we visited, because we visited so many times, he said, you people from Kenya, you don't seem to agree that this technology is helping to alleviate food problems. And I understand in your own country there is still some trouble with food. And now don't come here again if you are not convinced. Of course, he put that in a light note, but we took home. So South Africa has long history and experience in this technology. Number two, South Africa has great technical human resource and capacity. I can name a few if I was allowed to, but without naming names, I know a large number of experts in this particular field, and I have seen a number of them are lined up to speak to you later this afternoon. Number three, South Africa has great science technology infrastructure. I'm glad to see Jaftha is part of the team that we shall be discussing with here from the Department of Science Innovation. And we have had a long history of partnership with South Africa and a program called the Square Kilometer Array. We visited South Africa in Pretoria, and we were mesmerized by the extent of science investment in your country. We visited the Karoo in Western Cape, where we saw the radio telescope and incredible infrastructure in space science exploration. We also visited the center in Cape Town that manages a huge a computer system that analyzes big data in real time, showing even where cyber attacks are happening in the country. And later on, we went to the planetarium, a room where you look at the sky, at the roof, and you see the entire sky rotating there with a lot of tutorial happening. So South Africa, therefore, has this incredible science and technology infrastructure that it cannot be matched in many other places within this continent. And finally, you have a tried and tested regulatory framework. Your framework has taken through crops and products all the way to commercialization. In that regard, therefore, my rallying call is for you to harness these resources and make them work for the people of South Africa. Next slide. Thank you very much.
Okay, I'm just standing in here. One of the questions you'll remember when you registered, and the people that are on the NBT, what do I call it, Innovation Enabling Database. I'm going to interrupt myself and say, if you're not on that database and you want to be on it, just give me your details afterwards. It's just every once in a while when something major happens, I spread some information around there and try to get people to work together. But I interrupted myself now and I can't remember what I want to say. Oh yeah, I asked you, what do you want to talk about? And obviously regulation is one of the big things. And I got a lot of questions, and I still get a lot of questions about people asking, so what is the status of NBTs in South Africa? So the first place, so I'm just going to present what I know, the public knowledge about this. I'm not going to make any judgments or anything. I just want to show you what the status is with a very simple conclusion at the end. I start off in my title by putting NBTs in inverted commas. And I will talk in my own presentation just after this quickly about that. But NBTs is neither here nor there. We're here to talk about genome editing, which theoretically is one aspect of NBTs. But the detail matters when you talk about the regulation. So this is one of the points I want to make. The first piece of information, sorry that it's so small, the text, but you all probably know this information. If you do not know this, obviously this is public knowledge. It's published on Department of Agriculture, Land Reform and Rural Development's website. In October 2021, this was the public notification, and in red I underlined there, it says, based on the definition of GMO under the GMO Act, the Executive Council has concluded that the risk assessment framework that exists for GMOs would apply to NBTs. And this kind of set the regulatory framework for NBTs, including genome editing in South Africa. One of the aspects of that was actually, at the same time, they published new application forms. And part of the argument was that now, although all NBTs are regulated, we have new application forms that should somehow manage this regulation, and the word tiered was incorporated in the first place. With the idea, tiered obviously in my mind, it's about what I call a vertical decision. So if you have to fill in a document, Roy just referred to that. They have what he called a simple application form. You put in the basic information to say, this organism has the following basic characteristics, and based on that, they make a decision. When you do a GMO application, as you all know, we have a tiered process across the pipeline, which means if you just register your facility, you actually submit very little detailed information. When you go to field trials, so that's the contained use. When you go to field trials, obviously more of you is expected of you, and then when you go to general release, you really have to add all the data. So that's also a tiered process. But the argument here was that you have application forms, which my understanding would be then you differentiate clearly between, what we would call a GMO and the GMO light, whatever you want to call it, because NBT is a genome-edited product. Say a SDN, a single mutation in the genome, is still called a GMO. So you have to fill in this document, but somehow the application form will distinguish between the levels of information. But if you go and look at this information, especially at something like the general application, the tiered process doesn't give you really a vertical decision. It gives you a horizontal one where you select what is relevant to you. So it's not about the depth of information. The distinction is not about that. It's about what you fill in and not. At the field trial, it's a little bit, there's actually more choice, because there you can make a different differentiation, for example, between a GM plant and a medicine, which is obvious. You're not going to fill in the medicine information. So you understand it's a horizontal decision, but it's logical in my mind. One example of this is if you look at the one that's about food and feed safety. I'm just quickly going to read here. At the number 6 there of what you have to fill in. So in the first place, you see what is called here the core information is still a substantial amount of information. And then there's one here that talks about food and feed safety. But in this section, when you look at the details there, it's actually just kind of asking the hypothesis, is there potential issues? So it's a pathway to harm, a very high level description. And then if there's a pathway to harm, which basically in everything that you change the composition, or theoretically can change the composition, you have to fill in the rest of the, so here's your compositional analysis, all of those type of things you have to do is still ask here. So exactly how you can here say no to something and not having to fill in there is not clear to me. So the point that I want to highlight here is, your decision, and if there's really a difference in the potential amount of information that you will have to submit for an NBT, SDN1, for example, let me call something specific, a point mutation versus a full-blown GMO is not that clear to me. But in any case, we have new application forms based on the... Then what followed that is the appeal that was led by ACBIS, and I'm not going to talk a lot about it, but the bottom line is, on certain grounds under, I think it's Regulation 19, you can appeal the process. So you have 30 days from that original publication, which was October 21. By November, this appeal was submitted, and Annelies Crosby, that's sitting back there, knows everything about it. So if you want to discuss any of this detail with her, she is here. So this was the public, what do you call it, the media submission on that, or publication. Then that went through the whole process, and this was published, when was it? August. Where are we now? September. The end of August, if I remember correctly. It's about 3-4 weeks ago, if I remember. There's a date there. But again, I have to walk around. I can't stop. So I just want to read again here. So there's a description here, the background to this. And then, so this is the minister has to finalize the outcome of the appeal board's decision. And then she actually gives here the appeal board's findings, which upheld the appeal. So they said the decision by the EC should be, what do you call it, placed on hold, and they refer it back to the EC. Basically, if you go and read the report, that says it has to go back to the EC and they have to establish a fit-for-purpose regulatory framework. But then here, the minister says the decision here basically says the Executive Council decision to regulate NBTs under the GMO Act provides the appropriate framework to manage any potential risk. I should have read the first one where the minister made the final decision to uphold the Executive Council decision. So she, despite of the findings of the appeal board, said that the framework. So the bottom line of this presentation that on the status of NBT or genome editing regulation in South Africa is that all products of NBTs, including SDN1&2, and why do I highlight this? Because these are the products that Roy referred to now as well, and most of the rest of the world does not consider to be GMOs. So this is the bottom line. If you make any genome edited product, even SDN1&2, they are regulated as GMOs, and you have to go back to the application forms to be compliant. I just thought I would say one more thing, but I forgot about it now. Yeah, so I'm not going to take any questions on this. We have a panel discussion afterwards where you can say whatever you want and ask questions. And very thank you to Ben, who is an EC member, who agreed to join us for the panel discussion. So obviously you can't, change anything or answer potentially all your answers, but thank you, Ben, for giving us some insights that you can give to what's happening at the EC level. Sorry, then I have to do my presentation. So this wasn't mine. This is just in lieu of somebody talking about this stuff at the meeting. We tried to get somebody, obviously, but we're not successful. And then, so I've got a very short presentation, and I see we are running over time, so I'm going to try and squeeze this into 6 minutes. The only thing I want to do here is not, this is the thing I wanted to say with the previous. If you read all the documents and things, you would see clearly the reason why the decision of the EC is based on the interpretation of the definition of GMO. So there's no reference to risk assessment or risk base or anything. It's about the definition. So it's a legal interpretation. And I'll just leave it there. What I want to do is not talk about that, because it's not my place to talk about the legal interpretation, except for maybe saying that there are two published legal interpretations that do not agree. So the argument, and I will come to this a little bit later in this presentation, is the whole discussion about product versus process, which is quite complicated, and I'm not going to go into that today. But the bottom line is we do not say that the process interpretation is wrong, but we say there's potential for also a product interpretation. So there's this ambiguity, and both the published formal available legal opinions agree with that there's this ambiguity that we have to change. So I want to just talk about risk. So just the science basis of distinguishing potentially between GMOs and SDN1s and 2s. So basically what the rest of the world said and what my interpretation of the risk basis of that is. And the first thing I always use this when I have general audiences because it's important for them. But I think it's as important for us. We're talking about genome editing today. I just showed you the formal publications and what South Africa is still calling it is NBTs, of which genome editing is a subsection, and what I'm talking about, SDN1&2, is a subsection of genome editing. And those differences and differentiation makes a big difference. And this is the point I want to make with this. There's a lot of different things. You will see the European Union published their proposal for regulations is NBT techniques. So they clearly talk about the techniques, in other words, a process-based, and I will show you later why that has an impact on regulation. Then the UK just came out with their proposal, and they call it precision-bred organisms. So it's organisms. It's a product. Ironically, we have a genetically modified organism act. We don't have a genetic modification act. And then the Americans has always used genetic engineering, which is a very broad term that covers everything and brings its own issues. But within this context, sometimes people talk about applications like gene drives. You use genome editing techniques to engineer gene drives that has a complete different impact in the end of the day, and I will come back to this again. The bottom line is we need to talk about details. So coming back to what Roy also said, and which is very general international practice, case by case. You cannot manage these things differently. Okay, and then originally I had a good idea, a reason for sharing this, and then I wondered about it this morning. But I think, like Zamaza would tell you, the youngest person, of course, in our office, old people like history. And I'm getting into that stage now. But the point I want to make with this is we are not talking about this stuff for the first time. This has been discussed since the 1970s. So we're standing on the shoulders of giants. That's the point I want to make. And in terms of some of the risk principles that they published in those years, which is now almost 50 years ago, still apply. Other things that if you go and look at the history now, interpreting that meeting, it wasn't just about the science and the risks and whatever, but it was about communication. It's one of the things that we often talk about. And how to engage with the people and the experts in the environment to make the right decisions. So I think, obviously we can always learn a lot from history. So Paul Burke is the guy who basically led this, but this is Sidney Brenner, South African, that won the Nobel Prize. He's one of the major contributors, and if you go and look at the 1975 paper that they published, he was one of the authors, and then Maxine Singer as well. So, history of molecular biology, I think, recombinant DNA technology is interesting. They actually taught us this when I was an honor student, which is now also ancient history. Nature of genetic variation. So the only point I want to make here, natural breeding utilizes some forms of changes. I use it genetic variation because I do not want to talk about mutations or whatever, so I use it by design, a very broad thing. And the point I want to make with these little things here is most of these are based on the natural, when you have cell division or meiotic division, all those type of things. And there can be, a low incidence of environmental, this is chemicals or radiation or whatever that can impact the variability that you have in your offspring. In vitro breeding, when we started to understand this, we actually induced things like high energy radiation and chemicals and whatever in vitro to do exactly the same things. None of those were regulated as GMOs. They all regulated, always. Everything is regulated. Plant Improvement Act, food safety issues, there's lots of different regulations that talk to the products at the end of the day. Then we started doing genetic modification, a completely new organism. We said that should be regulated, that's it. And then now we have genome editing, which we can induce, if it's SDN1 and 2, mutations similar to those. And then if it's SDN3, and what you see is what I just show you, the tools now are a little bit different. We use the magnifying glasses to say this is the precision of this. We target a specific sequence, and then we cut it, and it's repaired endogenously, and then you may lead to. So the first point I want to make is those mutations are identical potentially. You can't distinguish with them. The second point I want to make here is that we decided to regulate those, and now that is exactly the same, although it's a form of genome editing, the genetic impact is identical, so we should regulate it, and we decided now to regulate this as well, where those two are not regulated. So this is what I want to talk about. So things that we do not regulate as GMOs, that variation comes from these type of things. I put natural in brackets there because this can happen naturally if you just leave a system, or we can enhance it through breeding programs and whatever, and force breeding between species that can, and stuff like that. So the point I want to make about that type of variation is, how have we managed it? That natural, I call it now, natural genetic uncertainty. So if you have a breeding program and you select, for example, different apples, there's a lot of nonsense coming out of your breeding program. Nobody has said in history, now we have to put in new legislation because that you see all of this genetic nonsense that's coming out. The only reason or ways that we manage it in the first place, there's no safety, there's no direct safety data. Even if you go and register a new cultivar, they just look at these type of the so-called DUS, distinguishability, uniformity, stability. It's important things in terms of genetic, but there's nothing directly about safety. Safety is additional things, you know. In the Department of Health, Agriculture also, and I forget all of the acts, but there's one act that looks at the safety of produce as well. And phenotypic. So we evaluate this thing. This is one thing that people forget. When we seem to talk and start focusing on the DNA, they forget that breeding is still part and parcel of this whole process. Again, Roy mentioned to you there, it's a formal part of their GM regulation, is that what they call the national trials, national variety trials. So you have to show that stability and stuff, just like you do when you register a cultivar. So why do we regulate? I'm not going to, you understand this, but the bottom line is there's certain things in certain products that you're allergic to. If you have a different product, you are not. So what we did actually with genetic engineering is when you potentially transfer that to a different organism, you transfer the problem. So my clarification of this is you created a unique, a new risk context. Because now suddenly this guy that potentially, you know, or always ate groenmealies, now suddenly he will have a reaction. And this is a basic example of why food safety is managed. I can do the same for environmental risks, and those two, of course. So the point I want to make is that natural variation has always been part and parcel of what we do. And we never regulate only as GMOs. Again, remember my slide earlier. We regulate food safety and environmental impact and whatever. There's certain plants, for example, that you will not be able to register because they are considered weeds. And then what we did with this threshold, we had this new potential risk, and we have to regulate. This says nothing. This relative risk categories that I have here says nothing about the amount of risk. You can still have unacceptable risks here. There's many plants that will kill you. So it doesn't mean this is safe and this is, per definition, unsafe. The same is true, obviously, then for acceptable risk. So just to put it in pictures again, breeding, in the end, you end up with a product that's a combination of your two parents. Mutational breeding here, you induce a genetic. So what is the thing that they share here is you limit it to that cells, or it's actually the what do you call it, the sexual reproduction barriers. You limit it to that amount of genetic variation. And there can be a lot of variation within that, but we've never regulated, basically because we're used to it. It's part of our history. Then we generated GMOs. Suddenly you have this new risk context, which I just explained, and we have to regulate it as GMOs. So in my mind, if you then do something in a different way, but you end up with something similar, I didn't introduce something new, then it should not be regulated, or I shouldn't say that. I say it is the same context, the same risk context as that. That's what I say. And then, of course, when you do genome editing with SDN3, it's the same context as that. So this is what it falls to me. So if you have a very simplistic technology development thing, just to try and explain quickly what process-based scope is. It means the difference between trigger, scope. So if you have a process-based trigger, it means when you use a certain technology, like we said now, if you use an NBT, that's the trigger. Everything that follows that, including all products, irrespective of the traits of the products, are regulated. So your process scope is wider than what you say, I'm going to do case by case, look at the product, and then I'm going to do this. So go and look at the history. Go and speak to the people that were involved in the GMO Act in South Africa and the people from 1975. Nobody ever made this distinguish. The thing came in when we started. We took science, we put it into legal documents. Now we come back. We don't go back to the science, we just go back to the legal documents and then interpret it from there, ignoring the science. But nobody spoke about process. Process was introduced specifically because it broadens the scope of regulation. That was the main reason. It doesn't have any risk bearing. And then one thing that people do not understand, if I say we should have product-based regulation, they say, but you can't ignore the technology when you do a risk assessment. But nobody said that. This is the trigger. When you do a risk assessment, you still consider everything because your technology, if you just look at GMO, the difference between bombardment and agrobacterium, for example, can have an impact on what your product looks like. So you do consider it, but it's not the trigger of regulation. So why is it only, what do you call it, a product-based trigger that makes sense? In the first place, if you just look at risk, what is risk? It's a hazard with some type of exposure, your risk hypothesis, that leads to some harm. And the risk gives you a kind of a estimation of the likelihood of the harm occurring and then the consequence of that harm. So if I talk about GMOs, which is the product, the organism, and genetic modification, the action, GMO, what is GMO in this equation when we talk about risk? And remember, this is risk. Nothing else is a risk. You can't bring in something else here. It's clear that the GMO is the hazard. This is why we regulate it as a hazard. But what is genetic modification? If you even can comprehend, how do I assess genetic modification's risk? Because if I don't have a product, there's nothing in which the risk is based. Just me doing the verb, the action of genetic modification doesn't relate to that. Go and think about every risk assessment that you've done in your life. It's about that product. That is the risk. And then we have this issue where you have the same process that can have different products that I showed already and vice versa. So it doesn't make sense. You run into problems if you do not focus on the actual source of the risk. And I'm not going to talk about this. The only point I want to show you, this is the original definition of GMO in the European Union, 1990, I think. Yeah, 90. Where they had, and we basically used that with some slight modifications and excluding this. So this is interesting. They had basically the same thing, but they quantified. This is exactly how it is in that article. They said then, there's certain techniques that are included and excluded. We left that, and now we have this ambiguity that I referred to earlier. And then the Cartagena Protocol, which everybody argues this is where we have to go to because we're signatories of the Cartagena Protocol. This is what we should use. And what they use here is a novel combination of genetic material, which is exactly the same thing that I talked about earlier. That novel combination is the additional risk category. And then the last thing, this is how complicated it gets. This is everything that we have. You have techniques that lead to certain what I call genetic impacts or classifications. So you can use whatever technique here to have what we call cisgenesis, RNAi, whatever, transgrafting. And I don't say this is absolutely correct. We can edit this and we can change this. The bottom line of what I want to show is there's techniques, genetic impact, and then there's applications. All of these we should consider in a risk assessment, but only one of these things actually carries the risk. And we then have to decide what should be, and again, this is an arbitrary line. But the point I want to make with this, some of them, some may be regulated, not regulated, some should be regulated, things like that. Standard GM technology, we know it's regulated, so it's on the right of this program. So the point is you can probably not draw a straight line in any case through this. We have to decide on exactly where the risk is. Thanks.
Thank you, Hennie. Ben, can I ask that you come and join us in front here? Ben is the Chief Director of Bio-Innovation at the Department of Science and Innovation. So he's just going to give us some input from government side. Just add in whatever comments you can. Okay, so if I came in this morning off the street and I listened to Roy and I listened to Hennie, I'd say thank you very much, case closed. Let's go ahead with gene editing. There doesn't seem to be any risk. But yet, here we sit. And South Africa is one of only 2 countries in the world who has decided to take the path of regulating gene editing in a more strenuous way, in the way in which we regulate GMOs. And just because we're the odd ones out doesn't necessarily mean that we're wrong and we need to jump in with the rest of the world. But that is what we are here to figure out. And we need public participation. We need participation from the myriad of experts that we do have in this country on gene editing, on GMOs. I think South Africa is really in a unique position in that we've really got a lot of experience in this regard. We led the charge for many years in the world, and especially in Africa. And if I'm not mistaken, I think we're the only country in the world whose staple food is a GMO. And it has been said before that we're actually have the biggest experiment on earth in terms of GMOs because of that. And as far as I know, and as far as any researchers that I've seen, there aren't any adverse effects. So I think South Africa's got a pretty good handle in terms of regulating these types of things. So the next step for us is then to properly assess gene editing, assess the technology, understand where the risks are, and then decide if we're going to go ahead and ease the process in terms of regulation so that we can roll it out more easily and quicker and cheaply, or at least cheaper than what GMOs can hit the market. And therein lies a lot of benefits. And I'd like to discuss that now this morning with Hennie and with Ben and with Roy. So Roy, we received very encouraging words from you this morning regarding Kenya. You rightly said that it took a lot of courage for you to take the path that you did. I think a key moment for you was understanding that your Biosafety Act didn't take NBTs into account, and that you actually had to change the law to move with the times. So what I would like to hear from you is if you could just explain your thinking regarding sustainable innovation and weighing up the risks, and how you decided to take that leap from being a country where you didn't even allow GMOs to reassessing a completely new technology, seeing the benefit in it, convincing the role players and the lawmakers to change the law and then roll it out, and in a relatively quick time.
Hello, can I go?
Yes, we can hear you.
Thank you, Julian. The point I want to pick up from here, just one. Oh yeah, thank you, Lindi. The point I want to pick up from there is you asked my thinking around sustainable innovation with regulatory systems that should be able to encourage innovation and at the same time to ensure safety. This is one of the balancing acts that a regulator in my position or in the position of the Biosafety Authority or the Executive Council in the case of South Africa is a delicate balance that calls upon a conscious attempt to ensure that we don't stifle innovation. Remember, Kenya and South Africa, for example, shares quite close or similar kind of architecture in the area of science, technology, and innovation. Before I took up this role at the National Biosafety Authority, I served at the National Commission for Science, Technology, and Innovation here in Kenya, which is mirrored by the Technology Innovation Agency in South Africa. We also have the National Research Fund, a fund that is dedicated to manage resources for research. Again, mirroring the research fund in South Africa. In fact, when we crafted the Science, Technology and Innovation Act in Kenya, we borrowed quite a bit of experience from South Africa. Now, having said that, therefore, it is important for a regulator in our space and also in the space of science, technology and innovation to ensure that the regulatory demands do not stifle research, innovation, and discovery. It is a delicate one, and like you have indicated correctly, it requires the sharing of ideas with policymakers and regulatory institutions such as the Parliament and other legislative arms of government. So in my thoughts, therefore, is to focus largely on the innovation and what that innovation has got to contribute to the socio-economic and well-being of the people. At the same time, focus on potential for biosafety or risky issues. For example, a pathway has just been demonstrated by Hennie about showing how the exposure to this results in this level of risk, and therefore, what risk are we talking about? So there must be a pathway to risk so that the regulatory aspects can, or interventions can come in. So my thoughts, therefore, in very short terms is that it is a delicate balance, but we must make a deliberate and a courageous move. I mentioned the word courage a number of times in my presentation, and that is what makes us move forward. We recognized, for example, in our case, that genome editing is not within the purview of the Biosafety Act, but then it is a technology within the modern biotechnology frame. What do? Do we sit back? Do we step forward, ask who else is handling this? What are they doing? We learn from the others and move forward. The achievements that have been made in Nigeria, for example, are largely a result of very courageous leadership within the Biosafety Management Authority of Nigeria by a gentleman called Lufas. And he was very courageous in picking innovations. A number of times in my country, I have been blamed of being a promoter, speaking too positively about the technology. But then I argue, if the technology is not taken up, if the technology is not with the people, what will I be regulating? I will have no job. So those are my thoughts, Lindi, and thank you for that.
Thank you, Roy. I think I just want to highlight there were a couple of words that stood out for me there, and the one was deliberate. And from what I'm very much hearing from you and from the department that you work is that there's a lot of motivation to innovate. And I think that is what is needed also. I think if there's a motivation to be innovative, then there will be a drive to be innovative and to look at these things and really to make work of it so that we can reap the benefits of it. Ben, I want to put you on the spot now. Just regarding the topic of innovation, you are from the Department of Science and Innovation. So what is the South African government's take on being innovative? Because there's been innovative and there's been reckless. So how is the department weighing up these two aspects to make sure that South Africa has access to cutting-edge technology that can really change lives, but making sure that the risks are balanced, but not necessarily allowing the overbearing risk to take over the process, if I can put it that way?
I perhaps can talk to your question through our bioeconomy strategy of South Africa, which was developed and driven by the Department of Science and Innovation. And it's really recognizing that innovation is central to the economy. We had a biotech strategy which said, let's do more biotech. We've now got a bioeconomy strategy which says it's the ultimate socioeconomic impacts that are so critical, and the department believes that innovation we believe it's the most important factor in driving economic development. Obviously, there are other inputs to economic development beyond innovation, but my department believes innovation is at the core of it. South Africa has got a very good track record in innovation. What we haven't done quite so well is manage the process, develop an enabling system, the policies and so on. But nevertheless, you read the documents of the government, and innovation is critically important. It's in all of our documents: the National Development Plan, the Bioeconomy Strategy, our 10-year innovation plan, our white paper on science, technology, and innovation. There's so many papers that are recognizing the importance of innovation. And so there is this justifiable question about the anomaly between driving the bioeconomy and having an overbearing regulatory burden that doesn't seem to match. And Hennie's spoken about why that is actually, how you unpack it and define what the risk is.
Have there been any discussions within the department about the socioeconomic impacts of gene editing in the South African context?
So genome editing is not mentioned in the bioeconomy strategy, but it's inherent in it. It's another innovation, another technology, and it's very clear that yes, this is designed to have socioeconomic impact in the terms of health of South Africans and beyond South Africa, in terms of agriculture and food security, in terms of industrial biotech, where enzymes and new products can be developed in the manufacturing process, and we're also talking about it in indigenous knowledge system valorization. So it is really well defined, yes.
Okay, thank you. Hennie, I want you to speak to us a bit about the socio-economic impact, and I think it's a very broad term, so I just want to highlight a few aspects that I do want you to speak about, and that is with regards to the impact that gene editing can have on the availability of seed, the price of seed for growers in South Africa, if it could bring the cost down, and if there is the opportunity to make more varieties available that are of better quality, especially if we look at the work that Kenya is doing with the crops that they are looking at and the innovations there. If there is an ability, if every country has got their own set of, their own group of seed that they're working on and we can freely trade, then surely that widens the pool of what is available.
Yes, I start with the easy one, is the variety that you can generate from this. So one of the arguments that's been made about genome editing, if you focus on the technical aspects, is, we reduced, let me start. There's a lot of barriers to entry, new cultivars, seed production, all those type of things. And that relates to things like cost, how difficult it is to do the technique, how efficient it is, do you have the technical capacity, all those things are technical barriers. So one of the arguments for genome editing is that many of those barriers we bring down. The terms I heard, and you will hear a presentation later today, where proof of concept takes you 6 months. If you compare that, for example, with GMOs, it's orders of magnitude difference. So all of those things are down, and this is why we really need to take a hard look at the regulation as well. So bringing those barriers down, what does it afford you? More people can enter the activity. So to me, the socio-economic things, one of the big aspects of that, I don't see that as government's responsibility only, especially when you start talking about developing products. It's societies. So you need entrepreneurs. So you will only get entrepreneurs in there if they will be able to make products, put products in the market, and make money from it, basically, in the end of the day. They will only be able to make money from it if people want to buy it, if there's a real product. So it's a complex issue on the one side, but it's fairly simple, the mechanisms of how it works. It's not, brain surgery. This is how business has been done always. So to me, and then the word, for bringing down all of these barriers, they said actually genetic variation, which I refer to, has been democratized. So more people can enter. So developing worlds, I get excited about the opportunities for developing worlds because we do not have these deep pockets, more than R1 billion to develop one GM line. Because you have that access, you can create jobs, you can create new things. So the other big barrier that it then brings down is, you do not have to be, it's not going to cost you $1 million, so you don't need a huge commodity to make more billions back. You can develop locally relevant small products. So it's a long way to say that variability, because of all the reductions in the barriers, we can definitely increase the amount of them. The other thing that accessibility to seeds becomes complex. So if you just look at the variability, whatever, I just say there's potential of increasing access to seeds and products and novel, niche products and all those type of things. But if we again now go back to the commodities, and somebody like the US or Australia that does not even regulate SDN1 at all, there's no notification, nothing, or other people that evaluate it at least and then it goes past. If they develop products now, but in South Africa it's GMO and they have to do all that food and feed safety kind of assessment for such a small market, they're not going to do it. So in that context, we're not going to have access to internationally developed, potentially, products there.
Thank you. I know with sorghum in South Africa especially, there's a big need for better technology in that regard, and because it's such a small crop, it's not really financially feasible for the big companies to look into that, and that's a reason why we see our sorghum yield hectares declining. So Roy, I want to pose the same question to you with regards to the research that you've already done, and you are particularly doing research on sorghum and making that a more viable crop for your farmers. Are you seeing that gene editing can bring in more solutions for your farmers and make seed more affordable to your farmers? Or what kind of impact do you see that having on food security in your country?
Thank you. Thank you very much, Lindi, once again. I want to touch a little, before I get to my question on what you asked earlier on the cost of seed or availability of seed arising from genome editing. Of course, I'm not an economist, but from my perspectives, I do not see a change in the cost or even in the availability of seed arising from this technology, because in fact, genome editing has been presented as a very cheap technology. I mean, easy to apply and almost able to do within the context of do-it-yourself video clips that we see in social media. So even the reagents that are required are readily available, and they can be used not in very complicated kind of laboratory setting. Number two, in terms of